Question, we have to find the expression for position vector of the ship. So let us recall the basic expression. If an object has an initial position vector of A and moves with a constant velocity B, the position vector is given by this expression, A plus TB, where A stands for the initial position vector and B stands for the velocity vector. So in this question, the A vector, which is the initial position vector, is 1, 4. And you can see the diagram on the left where the harbor is at the origin and the ship is at 1, comma 4. So by definition, if I connect the harbor origin with the ship, this HS will be the position vector initially. That is A vector. So let's write down A vector can be written as 1I plus 4J, or in the column notation, we can write like 1, 4. The velocity vector they have given already. So the velocity vector is 1.2 minus zero point 0.6. This is the B which we require for this expression. Hence, putting both the values, we will write down the vector R as 1, 4, which is the initial position vector, plus T times the velocity vector, which is 1.2 minus zero point 0.6. And that's the answer for part A. Moving to part B. Find the time at which the bearing of the ship from the harbor is 45 degrees. So let us understand the concept of bearing when the angle is 45 degrees. So have a look. If the bearing is 45 degrees, that means the angle with the north is 45 degrees. Here, consider point B as the north. Whenever the angle is 45 degrees, so consider this right angle triangle, tan 45 will be opposite upon adjacent. So BC upon AB. Tan 45 is 1, and that's why we get BC and AB are equal. We say the x component of the displacement AC is equal to the y component of AC. In part B, we are given that the angle required is 45 degrees. So we have to use this concept, x component and y component are equal. In the part A, we had found out the vector equation. So individually, let us identify the x coordinate as well as the y coordinate. X coordinate will be 1 plus t into 1.2 and y coordinate will be 4 plus t into negative 0.6. So let's write that down. X will be 1 plus 1.2 into t and the y component is 4 minus 0.6 t. If the angle is 45 degrees, which is in this particular case, so we will equate the x and y components. So let's do that. The x component, let's equate that with the y component. If we simplify this expression, we'll get 1.8 t equals to 3. This implies t will be 3 upon 1.8. Let's simplify this. So we'll get 10 upon 6 or 5 by 3. So 5 by 3 is the time after which the bearing of the ship is 45 degrees. Now, the question was to find the time at which the bearing of the ship is 45 degrees. We already have found the t, but initially observe in the question they have given, the starting point was 1 p.m. So we'll have to add the 5 by 3, which we have gotten, to 1 p.m. And let's do that. So the time, final time which we require is 1 p.m. plus the 5 by 3. Now, 5 by 3, if you simplify, is actually 1.66 hours. Let's convert that into minutes as well. So 1.66 we can write as 1 plus 0.66. So 1 hour and 0.66 hours. So let's convert 0.66 hours into minutes. So we multiply 0.66 only with 60. That will give us the answer in minutes, which comes out as 40. So 5 by 3 incidentally is 1 hour plus 40 minutes. Now we need to add this much time to the original time of 1 p.m. So 1 p.m. plus 1 hour is 2 p.m. and we add another 40 minutes to it. So the final time will be 2 p.m. 40 minutes, which is basically 2:40 p.m. And that's the answer for part B.